Yes, sir. You're right underneath the nest. Why would that be weaker if you're right next to it? Well, let's talk about that theory. The closer you are to something, wouldn't it be stronger? I don't know, buddy. Sorry. Good morning. All right, so today we're talking about dilations. So what is a dilation and how does it differ? Can anybody tell me what makes a dilation different? Do you remember we talked about it in the first couple lessons? What makes a dilation different than the other three we've talked about? What about the size? The shapes? What is a dilation going to do to the size that the other ones didn't? It's going to change it. It's going to change the size of our image. So a dilation is the only transformation that changes the size of our image. Okay, so a dilation changes the size of our image, and I need to change the size of that so y'all can see it. No, I'm sorry. Okay, a dilation can be larger or smaller than the preimage, and instead of producing a figure that is congruent, what does congruent mean? Yep, same, equal. It's going to create a dilation produces a image that is similar. So it creates an image that is similar. What was the other fancy word we used for similar? Nope, that's when it's the same. That's when it's congruent. Started with a P. Do you remember? Proportional. Like a little word game right there. We're just revealing letters until we figure it out. So instead of producing congruent, also known as equal figures, like reflections, translations, and rotations, our dilation is going to produce one that is similar. So in our three examples, you got the purple star. What do you think? They are similar. You are not wrong, but they're even more what? Congruent. So these guys are congruent. So it's probably one of the first three. Looking at our yellow sun, did our image get smaller or larger? Smaller. So we call that a reduction. And then looking at our blue square with arrows coming out of it, did our image get larger or smaller than our preimage? Larger, so we call that an enlargement. That's what the old optometrist does to your eyeballs. He enlarges them so he can see inside, see what's crack-a-lacking. Too early for that. All right, so some of our properties. Come on, thingy. All of our points move the same distance, the same direction along a line through the center of the dilation. Remember, what do we call same distance, same direction? We call that a vector. Points on our preimage are always labeled ABC. Points on the image are labeled A prime, B prime, C prime. And each time we add a transformation, what do we add? Another thingy, another apostrophe, right? So all links connecting our vertices are dilated by the same scale factor, R. So you'll see this guy. You may see it labeled as K, but for this sake, we're going to call it R. So we've got three rules. The first one, what are those two boxes? Come on, Algebra 1 brains. What do those two boxes represent? Absolute value. So if the absolute value of R is greater than 1, it's going to be an enlargement. Oh, Peter, spell enlargement right, Sean. So it's going to be an enlargement. And what do we say happens when we enlarge something? It gets bigger. Our image will be bigger than our preimage. If the absolute value is between 0 and 1, the dilation is a reduction, which means it gets what? It gets smaller. And finally, just because they want to mess with us, if the absolute value of R is equal to 1, it's going to be congruent. So it's a congruent transformation. They may just be trying to flip it for us. So we've got three rules. Absolute value of R is greater than 1, it's an enlargement. Absolute value of R is between 0 and 1, it's a reduction. And if the absolute value of R is equal to 1, it's a transformation. Where you've got to be careful, because a lot of people associate that second rule with any fraction. Is that true? Could you say any fraction is automatically a reduction? Mathematically speaking. Could you say that? So if I told you 1/2, would that be an enlargement or a reduction? It'd be a reduction because it's between 0 and 1. In the same idea, what if I told you 3/2? Enlargement or reduction? What's that? Why? Good. So you've got to be careful that they don't trick you where you see a fraction and you automatically assume reduction. Our fraction must be between 0 and 1. They are going to try to trick you. And by they, I mean me. It will happen. And then you will call me evil and we'll move on. Okay? So we've got a formula. So we'd say A prime. So basically our image, let's just say A prime, B prime, is equal to the absolute value of our scale factor. Can y'all tell that's an R, maybe? The absolute value of our scale factor times our preimage. So our image is equal to the absolute value of our scale factor multiplied by each one of our preimage terms. So for example, if I said A was 3, 2, and we want to multiply it by a scale factor of 3. We're going to take that 3 and multiply it into both elements. So it looks like A prime equals the absolute value of 3. Don't put a parenthesis there, dummy. Multiplied by 3 comma 2. So what would our new preimage be? Our image be? 3 times 3 is 9. 3 times 2 is 6. Dilations are super easy, guys. We're just taking our scale factor and multiplying it into both. Pretty cool, huh? We can also derive our own scale factor. So if we know the measurement of a figure, we can do that by counting boxes or using the distance formula. We're just going to count boxes for now. We can determine the scale factor. And we're going to take our image length, Is that our new figure or old figure? New figure, old figure? New. How do we know it's the new one?
I don't know.
Sure you do. Why do we label it image and preimage? Yeah, so we can identify it, and then we're going to divide that by our preimage length. And that's our old. So we always go new divided by old. So we've got two formulas with dilations, scale factor times our preimage. And then to find our scale factor, it's image divided by preimage. Y'all ready to put it into action? Maybe? Yeah, let's find out. So some of our examples. Find the measurement of the dilate image or the preimage using the given scale factor. And then just for fun, we're going to determine whether or not it's an enlargement or a reduction. So it tells, number one tells me Mn equals 3, R equals 3. So what is M prime, N prime? So what's our scale factor here? Right, so that's that. So we're going absolute value of 3. Come on, right thingy. So M prime, N prime equals the absolute value of our scale factor multiplied by what? 3. What's the absolute value of 3? 3. What does an absolute value do to a number? No matter what, it's going to make it positive, right? So what is the length of M prime, N prime? 9. Is this an enlargement or a reduction? Why? Okay, you're not wrong, but how do I know it's an enlargement before any of that? Why is it an enlargement and not a reduction? What do you mean it's not a fraction? You got an answer for me, Evan? Yeah, what you got? Yeah, the absolute value of R, in this case it's 3, is greater than 1. All right, let's look at number 2 because it's a little different. What did they do on 2 that was different than the first one? They gave me the image and want me to find the preimage. So they tried to be a bunch of sneaky snakes. So they gave me the image and they want me to find the preimage. And that's okay. We're just going to use our basic algebra skills to set up our formula. What was our formula before? We would say m prime n prime equals what? What does m prime n prime equal? The absolute value of our scale factor times our preimage. So we're just gonna, we set it up just like that and we plug in what we know. What do we know in this problem? What is it? What's the prime? So what's our image? 7. What else do we know? What is our absolute value? 21. And then our unknown is mn. When we're solving linear equations, what's our number one goal? Solving linear equations, what's our number one goal? What, on the left, on number 1, what did we do? What was our number one goal for number 1? Try to get the answer for m prime n prime. So what's our number one goal for number 2? We're trying to solve for what? Mn. Don't do that, you rascal. Please hold. The next available doctor will be with you. Come on, you slippery rascal. Jags cut for net. Take that. Did it break? I broke it. Take that, technology. It's okay. We can fix it. Maybe. Oof. We got some spinning wheels. We're just looking around. We don't know what's going down. Go ahead and turn the old AirPlay back on. For those of you viewing at home, we have a technological issue. And we're back. So linear equations. Come on, guys, think. If I told you, let's go back. Let's get in our time machine and travel back to the year 2020 to around, no, maybe 2019. When did y'all do linear equations? Last year around this time? Maybe? You don't remember? If I told you 3 equals 4 plus y, if I just gave you that basic linear problem, what would your goal be there? Solve for y. We want to get y by itself. So what's the difference in that and what we're doing right now? More letters. Well, if that's what's messing with you, what if I did this? Let's go ahead and take that rascal off of there. You feel better now? No? All right, so we're going to, what's the absolute value of 21? 21. So we've got 21m. Y'all told me the ultimate goal was to get the variable by itself. How do I get m away from 21? Divide. I'm going to divide by what? 7. Why would I divide by 7? 7 is not with m. I'm going to divide by 21. I want to free that variable from the oppression that is the number 21. So we divide 7 by 21. Oh, let's go back to red. 7 divided by 21 now equals m. Are we complete? Can we reduce 7 divided by 21? Yes. You guys got them fancy calculators? Because they will do fractions for you. Did y'all know that? In your calculator, do 7 divided by 21. So 7 divided by 21. Then I want you to hit the math button. Oh, come on, math. What's that? It's going to give you a decimal, right? But so 7 divided by 21, hit math, and then frac. Math frac. 7 divided by 21, math frac. Yours is a little different, Wilmo. I'll have to show you on this. You've got like a little, so at the top, towards the top of yours, you've got something that looks like this. So when you put 7 divided by 21, you're going to hit that button. Do you find it? Yep. So what does it tell me? 7 divided by 21 reduces to 1/3. It says error. Ruh-roh, Raggy. What? I don't know. What'd you say? And I'm going to put that variable in there so it doesn't scare anybody away. Now, again, tricky. Was this an enlargement or a reduction? Why reduction? What do we base our enlargement or reduction off of? The R. So was this an enlargement or a reduction? Enlargement. Why? R is the absolute value of R is greater than 1. So don't let that answer fool you. It's just there to mess with you. I told y'all they'd be trying to trick you. Math teachers are a whole bunch of sneaky snakes. We just have conferences about how we can trick students. All right, let's do one more. It says AT equals 15. R is 3/5. What is A prime T prime? So I know my answer is going to be the absolute value of R times our preimage. Plug in what we know. What do we know? Okay, we know R is 3/5. What else do we know? AT is 15. And we're trying to solve A prime T prime. First off, what's the absolute value of 3/5? It's just going to be 3/5. Again, your calculator can be your best friend here. If you put it in your calculator just like that, parentheses 3 divided by 5, parentheses times 15, it's going to give you your answer. Or, just because that way you're telling it it's a fraction. Or we could cross cancel. How many times does 5 go into 15? 3. 1. 5 goes into 5 once. 5 goes into 15 3 times. So you calculator, folks, what'd you get? 9. Us freehand math, folks, what'd we get? 3 times 3 gives me 9. So guys, the more comfortable you get with your calculator, the better, because when you get to those dadgum standardized tests, when it's like you've got 45 minutes to do this math section, the faster you can pop stuff into a calculator and get an answer, the more comfortable you'll be, and you don't feel like you're panicking to get something finished. Does that make sense? So we're going to practice fractions a lot with our calculators. All right, is this an enlargement or a reduction? Why? Why is it a reduction?
I thought 3/5 would be fine.
Why would it be an enlargement?
I don't know if it's bigger than 1 and 3/5.
So our enlargement or reduction is based solely off of our what? R, which is called our scale factor. So our scale factor is 3/5 greater than 1. If I have $5, right, that would be a whole. If I have $5 and I said, hey, if you give me 3, who has more? I've got 5, you've got 3. Who's got more dollars? I do. So is this greater than 1? Yes. Why? Why would that be greater than 1? Bigger number on top is smaller. It's okay. How about this? Let's check out the old Wabbit. Let's see what the Wabbit tells us. You wascally Wabbit. So if I pull up my calculator, maybe, I broke it. Maybe, there it is. All right, so if I pull up my calculator, right, and I say 3 divided by 5, is it going to be bigger than 1 or less than 1? Less. So is it a reduction or an enlargement? Reduction. Why? Okay, so let's take a peek now. If I hit math, look at that little frac guy right there, and I hit frac, it tells me my answer is 3/5. Let's do another fraction one, just because y'all make me nervous on that. Ooh, let's do one. Let's do number 4, because number 4 is a little wonky. It gives us our image again. Wants us to find our preimage. So remember, A prime, T prime equals the absolute value of R multiplied by the preimage. Plug in what we know. What do we know? Our prime is 12. Scale factor is 3/7. Why do you keep putting a parenthesis, dummy? That makes AT out here. What's the absolute value of 3/7? It is 3/7. Solving a linear equation, what's the number one goal? Isolate the variable. Now we got to go way back into the Algebra 1 calendar. I've got a fraction. How would I get that fraction to go to the other side? What's that? Remember, I got to create a 1 on the right side, and whatever I do to the right side, I got to do to both. I flip it. So that's called multiplying by the what, Evan? You don't remember what it's called? Multiplying by the reciprocal. You do remember, my guy. So 7/3. So Evan is 100,000% correct. We are going to multiply both sides by the reciprocal. Because what happens on the right side? So if we've got, how about we'll just do the math out. So 3/7 times 7/3. We're not even going to cross cancel or nothing. When you multiply fractions, you multiply straight across the top straight across the bottom. 3 times 7 is 21. 7 times 3 is 21. 21 divided by 21 is, survey says, 1. So when you multiply by the reciprocal, you are creating a 1. Just like up here where we divided by 21, we were just creating a 1 because we want to isolate AT. The left side, what's the left side tell us? 7/3 times 12. You're like, Coach, I don't feel like doing all that math. Well, remember, our calculator can help us solve fractions. So in parentheses, 7 divided by 3. What was our number again? 12 times 12. Coach Oliver hates decimals. But look at that. We don't got to deal with decimals. What's my answer then? 28. So that gives me 28 equals AT. Enlargement or reduction? Enlargement or reduction? Why? Good, because my scale factor is less than 1. Perfect. We got to do some practice on this stuff, huh? Y'all in basic algebra. Looking at me like I got 2 heads. All right, so we're talking about dilations on a coordinate plane. If our preimage, P, the point P, X, Y, is the dilation centered at the origin with a scale, we already talked about it, right? What are we going to do with our scale factor? We multiply it into, oh no. You multiply it into both. Come on. People now, smile on the brother. Sorry, guys. 1 second. There we go. So it's going to be R times X and R times Y. So whatever our scale factor is, we just multiply it into both. So you can kind of see it in these examples at the bottom. The black smaller triangle multiplied by a scale factor of 2. So what would that rule look like? XY transforms into 2x, 2y. Now my red triangle gets smaller by a scale factor of 1/2. So it'd be what? 1/2 x, 1/2 y. In our final one, a scale factor of 1, xy just becomes xy. They're just trying to be sneaky. It really just mapped it on top of itself. No rotations, no translations, no nothing. All right, y'all ready to graph some figures? Yeah, we are. Y'all gotta wake up on a Monday. So triangle JKL with the vertices of J24, K42, L0, -4 with a scale factor of 2. So we can do it twice. So it wants us the first one do it with a 2, second one do it with a 1/2. Let's just worry about the first one right now. We're gonna go ahead and take out that 1/2. We're just gonna do number 1. So let's go ahead and graph our preimage. 2, 4, right 2, up 4. J, right 4, up 2, K, and then down, -4, L. So before we even do math, do you guys think enlargement or reduction? Why enlargement and why reduction? Scale factor is 2. Is that greater than 1? Yes. So it's going to be an enlargement. So that looks like, what are you doing, dummy? XY transforms. What's our rule here? It's going to do it to what? 2x, 2y. 2x, 2y. So J prime, 2 times 2 is 4. 4 times 2 is 8. Is everybody comfortable with that? Or I go too fast? Or do I need to draw it out? I can draw it out. K prime. So 4 times 2 and 2 times 2. So what's K prime really? 4 times 2 is 8. 2 times 2 is 4. And then we got old L prime over there, where we've got scale factor of 2 times 0 and 2 times, is that -4? Two times 0 is? Any number times 0 is always 0. What about 2 times -4? -8. So we can go ahead and graph our image now. And you guys said enlargement, so let's see if we were correct. So we got 4, 8. I'm definitely going to mess this up, so I'll just make sure I'm on the right path. J prime. And then K prime is 8, 4. And L prime is -8, 0, -8. So yeah, absolutely an enlargement. %1,000%. All right, let's do one more together, and then I'm going to let y'all do the other two by yourself before y'all start your homework. So down here at the bottom, determine what scale factor was used to create the dilation. So we need to find a common side. So, and the easiest sides are going to be either straight up vertical or straight up horizontal. That way we can just count boxes. So if I find a common side for this pentagon, what do you think? Probably the bottoms, right? Because everybody else is crooked and we'd have to do the distance formula, and you guys ain't feeling that much math this early in the morning. So if we go, we're going to compare the image and the pre-image of the bottom. So it's important here, image goes on top, pre-image goes on the bottom. Which colored hexagon is our pre-image? The black one, which makes the image the red one. So what is the length of the red base? How many units across? So we got 1, 2, 3, 4, 5, 6, 7, 8. Did y'all get 8? Maybe? Let me double check myself. 1, 2, 3, 4, 5, 6, 7, 8. How are you guys getting 9? Okay, so we start right here, right? This is where we start. 1, 2, 3, 4, 5, 6, 7, 8. Are we going with 8 or are we going with 9? Let's probably go with 8, right?
I swear it's 9. I swear I got 9. That's weird.
Okay, so we've got 8 for our image, and our pre-image is, can we agree on this one? If we start right here, 1, 2, 4, 3. So we get 3. So what's our scale factor? R equals what? 8/3. All right, I want you guys to do the graphic one. This time do the fraction, because fractions are your friends. You're going to do this one, and then find the scale factor on the bottom. And then once you do that and I check it off, you can start your My Math Lab. Hooray, My Math Lab.